This is my video showing off my implementation of the 8 puzzle solver that uses depth first search, breadth first search, uniform cost search, greedy best first search, and A-star search with 2 different heuristics. The first thing I did was make a node class here, and this takes in a state, a parent, action, depth, cost, and then total path cost. I used to have this as a helper function, but then I just computed it each time I generated a new node. And then here's my successor function, and I basically just check um, if 0, for example, in this one is not in the far right column of a 2D array. So it would be index 2, 5, and 8 in a 1D array. Um, then I generate a new tile that for left. And then if it's not in the first column or the leftmost column, then I generate one for the right, and so on and so forth. And that gets called in my main loop, but it just returns those newly generated states for whatever available actions there are. And then I just made a little swap helper function just to help out this so it's cleaner. Um, and then misplaced and Manhattan, these are my two heuristics for, well, this is for uniform cost search and A-star search 1, and then this is for A-star search 2. I just decided to make these a part of the class because my end solution had no other helper functions, so I just wanted to be clean like that. I'm going to demonstrate it running really quick. So I run, and we have any choice you want. Breadth first, say, then easy, and then we'll get nice output here. So solving, goal state found, printing output, start state, each move, and goal state reached, and then length of solution path, total path cost, nodes popped off queue, and max size of queue. And we can do this for a couple other ones. Let's do A-star 2 on easy. It's a really short one. Some where it takes a little longer. Let's say greedy on hard. Those ones are way bigger. Then next, I first implemented the search algorithms as 5 separate functions that were just getting called from my main loop down here. I'll show that in a second. But then I just condensed it because I realized how much code was being just rewritten and how insignificant the differences between each of these really were. So this is the main loop where I basically just say if the length of the queue is greater than 0, keep going. And this one has a return in here, so if it does find the goal state, it doesn't only wait for this. But then I initialize my repeated state checking up here, initialize the queue with the initial state that gets passed in, which is the configuration chosen by the user. And then I track nodes popped and max queue for output statistics. And then here we pop off the queue, we check for goal state. If it's not the goal state, then we keep going, generate new nodes. Then we check all those new nodes. We check all those new nodes, and if they're not in previous states, then we append it to previous states so that we have our repeated state checking for anything that we've seen. Then here, if algo is BFS, I insert at the beginning because I'm just popping every time from the end. So this will give me FIFO behavior. I say this in my comment. And then everything else I just append because this is proper for DFS, and then the rest of them all have queue sorting, so everything's good there. And then just here, I have an algo parameter that also I pass in that just dictates which algo is currently running. And so here's my decision tree where I just do the proper sorting for either UCS, GBF, or A-star 1, A-star 2. Then just I return false, couldn't find goal state, should crash before this happens, or kill it, or whatever. This never happens.